Welcome to the Resource Allocation Decision Tool Help Video number 3. How confident am I in my rating of effectiveness? My name is Terry Haines. In the Resource Allocation Decision Tool, we have asked you how effective a particular option may be in addressing the health problem. Following on from this question, we ask you how certain you are in the judgment that you have made in the effectiveness of this option. We give you the response options of being very certain, somewhat certain, or uncertain that your judgment of effectiveness has been correct. In our previous help video, when assessing the effectiveness of an option, we gave you 5 keys to success when using research in making resource allocation decisions. In this video, we're going to cover some similar territory for the first 3 of those success keys and examine how these keys can help you to also understand how certain you can be in the effectiveness of the intervention. Remember that we are trying to make a statement about causality. Does having a particular intervention cause a particular outcome? Whenever we are looking at research questions and research papers that have been answered in the past, we must always consider how closely they resemble the particular question that we are confronted with in our resource allocation decision. Is it the same population? Is it the same intervention? Is it the same sort of comparison? Now, every time there is a research paper, it reveals a certain part of a broader picture behind the research field. We want to make sure, though, that research papers that have a very relevant research question and that reveal very important pieces of the picture that we are interested in are given more weighting. So always be discerning with the research question that is being asked in the research paper and the research question that you are confronted with when trying to allocate resources. Studies with stronger designs are less likely to have confounded or biased results. The National Health and Medical Research Council has described 4 levels of evidence, the highest level of evidence being a systematic review of randomized trials. The second highest level of evidence being randomized controlled trials. The third and fourth levels of evidence have pseudo-randomized designs or concurrent control designs, which are commonly seen in health services research literature. It's important to note that systematic reviews of pseudo-randomized trials or comparative studies with concurrent controls or any other level 3 or 4 evidence only assume the same level of evidence as the trials that made up that review. So if there are only grade 3 or level 3 trials in a systematic review, that's the maximum height up this evidence hierarchy that systematic review is allowed to be placed. There can still be problems, though, with meta-analyses and systematic reviews. Here we see a systematic review and meta-analysis of 2 studies, one examining group therapy and one examining individual counselling for treatment of depression. Their combined treatment effect is 0.62, which is a near significant finding. However, what is this review actually telling us? Just because we can pull the results of these 2 studies doesn't mean that we should. Is group therapy really the same as individual counselling? So meta-analyses can sometimes fall into the trap of merging studies that have quite different interventions that they are combining the results for. When you read a meta-analysis like this, you should always be wary of what the actual question that is being posed is. In this review, it is not asking what is a combined effect of group therapy or individual counselling, but some other question because group therapy and individual counselling, I guess, could be conceived as being non-pharmacological therapies, but this is a very heterogeneous group of interventions, and it doesn't necessarily make sense to combine them in the same meta-analysis. Also, when considering a meta-analysis, consider also the quality of the individual studies involved, because the old maxim goes, if you've got garbage going into a meta-analysis, you'll have garbage coming out. So be aware of what standards the meta-analysis authors placed on including or excluding studies in their particular research. Now, there can also be problems with randomized trials down to the next rung of level of evidence. There are many checklists available that can help you to understand that whether there are factors that might predispose a study to having biased or confounded results. One example is a Pedro scale, and a particular item in that scale is whether there has been adequate concealment of the random allocation sequence from people recruiting participants into a trial. This is also a very important factor in the Cochrane collaboration reviews of randomized controlled trial quality. Now, there may be factors specific to a particular field that do not appear in these checklists. In one of my research fields, I look at the prevention of falls in hospitalised older adults. Relying on incident reports alone in falls prevention research in this field has been shown to be a very substantial flaw in this particular field. However, this design factor does not appear in these conventional checklists, so you may also need to understand the individual context of the field in which you are reading about and apply criteria that don't necessarily appear in these checklists. The third key to success was that larger studies were more likely to have precise estimates of treatment effects. Here we see a meta-analysis of 3 studies that we looked at in the previous help video, looking at whether drinking coffee increases running speed compared to drinking water. Each of these studies has only 20 participants. So when we see our pooled effect, we have a shrinking of the confidence intervals to some extent, but if there had been one study that had been 80 participants and had the same data distribution, then we would have an even narrower overall treatment effect confidence interval. So just because there's 3 studies doesn't necessarily make it a stronger result than if there is only one study, if that one study has more participants in it. So don't be deceived by having many studies if they're all very small compared to one study that is very large. So we return to the reader question. How certain are you that this judgment of effectiveness is correct? It is reasonably straightforward to differentiate between being uncertain and somewhat certain when we add the qualifiers that there is for being uncertain only anecdotal or no evidence, whereas for being somewhat certain there is some evidence available, but there's some limitations in the amount or quality of that information. Differentiating being somewhat certain from being very certain, though, is a bit harder. To be very certain, what we'd really be looking for is research that has been well designed, that doesn't have a high risk of being biased, and that has produced reasonably narrow treatment effect estimates. Those confidence intervals that you can see in this particular meta-analysis are quite narrow. So we're 95% certain that the rate ratio for this particular outcome being falls as a result of exercise programs is somewhere between 51 and 77. However, don't be deceived again by the fact that there is many studies here. If there was 1 or 2 studies, but they were very large studies, you could get a similarly narrow confidence interval around this combined treatment effect. But it is that nice, precise estimate of effect combined with well-designed studies that have contributed to that treatment effect estimate that gives you greater certainty, in fact being very certain, that a particular intervention has been effective. So you can be more certain in results like this.